Thank you all for joining. Thank you all for organizing this workshop. And yeah, so today I'd like to discuss with you and argue against a particular claim, which this doesn't work. Okay, which was put forward by Matarese paper 2022 in field studies, where she claims that the hypothesis that you are agreeing with that provides a better explanation for the EPRB correlation than the explanation provided by standard quantum mechanics hypothesis, and so by our best scientific theory. And she also claims that in light of this, we should feel the pressure to take this radical hypothesis seriously when doing science and scientifically informed metaphysics. So actually, in her paper, we can see two different versions of the same claim. One version, which is repeated at least 4 times, is that the brain-in-a-vat hypothesis or any other radical metaphysical hypothesis provides a better explanation than any of those alternatives. And then a weaker version that says that actually it's more challenging than it first appears not to accept the brain-in-a-vat hypothesis. But I can easily combine both versions by saying that probably according to Emery, given that the brain-in-a-vat hypothesis provides a better explanation than its alternative, then it's more challenging than it first appears to reject it and not to consider it seriously. My claim in this talk is that actually the quantum mechanics EPRB correlation cannot be explained by any radical metaphysical hypothesis, and so we should not consider them for any scientifically informed metaphysics. They have no explanatory power at all. Why I think that this literature and this problem is relevant? Because there is actually lots of literature going on whether we are living in computer simulation, both in the philosophy and also in the physics literature. And on one hand, the philosophers are trying to engage with this question. On the other hand, the physicists, some of them think, oh, this is just a stupid philosophical question, but others actually engage with it. Also, it's relevant given some claims put forward as early in 1998 by Salmon, say that actually quantum mechanics cannot explain. It does not have any explanatory power, cannot provide any explanation in light of the Einstein-Podolsky and Rosen paper and the EPRB correlation. Okay, so my method in this talk is to try to combine the metaphysics literature on one hand and the methodology of science on the other hand. So when we want to do scientifically informed metaphysics, then we also want to take into consideration studies in the methodology of science. And so when we talk about explanation and explanatory power, we should bring into dialogue both the metaphysical discourses of what explanation is, but also scientific practice. And so I'm going to revive in this talk some kind of standard scientific methodological principles about the explanatory role of our hypothesis and what the standards of explanation should be. So the outline for today is that I will just very briefly say what the EPRB correlations are. Then I will make a distinction that Emery assumes in her paper between the ordinary world hypothesis versus the radical metaphysical hypothesis. Then I will present Emery's argument and the first reason to reject it, and then I will try to build something positive. So the parts and constraints of my talk will be next, trying to dissecting the explanatory power, what it means to provide a better explanation, what does it mean to have explanatory power, and then just trying to argue that the radical metaphysical hypothesis do not provide any explanatory power in light of principles in the scientific practice of what explanations are and should be. So we have here the classical scenario of EPRB correlation. So we have a source that emits particles like electrons. They can be, for instance, with spin half, and then basically the source emits a particle in the opposite direction. And then you have this dialectic magnet that can be oriented with different angles. And then if we set up the standard dialogue in a particular way with particular kinds of orientation and the left and the right side, then basically the two particles, well, if one goes up, in order to have a spin up, the other will go down, and vice versa. If this one goes down, then the other one will go up, okay? So then anytime one particle goes up, and then the other must go down, and vice versa. This, of course, if we prepare the particles in a singlet state, okay? So then the problem, according to Emery, is, well, this kind of correlations cries out, calls out for explanation. And the literature is going to tell us that it can't be causal signal, it can't be common cause, okay? So how can we explain these correlations, okay? Well, at this point, we have two different families of explanation that we can appeal to. We have the ordinary world hypothesis kinds of explanation, and we have the radical metaphysical hypothesis kind of explanation. And the ordinary world hypothesis are those that presuppose the reality of the manifest image. So we see tables, we see coffee because there are tables and there are coffee in front of me. And if we buy into this kind of explanation, then normally the literature is going to give us a three option. The first option is all those that actually do not give any substantive explanation at all. She doesn't say exactly who these people are. I think Humeans. Second, the second option is to explain the EPRB correlation by appealing to some kind of non-local dependence, non-local relations that is primitive and fundamental between the spin of the two particles. And the third option is actually to appeal to the reality of a higher dimensional space, okay? Like David Albert. And then the behavior of the spin of our particles just emerges, and it's emergent reality. It emerges from actually just one particle, one existing particle in our configuration space, okay? On the other hand, we can go for the other family of a hypothesis, the radical metaphysical hypothesis. And those are the ones that presuppose the falsity of our perception. So we see tables, we see coffee, but there are no tables, no coffee, nothing. So this is, for instance, the brain in a vat hypothesis. So we are actually just the brain in a vat. And all things that we see, they are just hallucinations, okay? Or we have the simulations hypothesis. We live in a simulation, okay? Or the Boltzmann brain hypothesis, we're just the brains fluctuating in the universe, okay? So then Nina Emery's argument is the following. So this is how I reconstruct it. Any substantive explanation that introduces less explanatory novelty than is introduced by its alternatives provides a better explanation than its alternatives, okay? So then we see that the brain in a vat hypothesis provides a substantive explanation of the EPRB correlation. We also see that the BIV introduces far less explanatory novelty than is introduced by its alternatives. So we should conclude that the BIV provides a better explanation than any of its alternatives, okay? And then she also adds the following: given the prominence of inference to the best explanation as a criteria for theory choice in science and scientifically informed metaphysics, we have the pressure to assume a BIV over its alternative. Okay, so in the first part of her argument, she establishes that the brain-in-a-vat hypothesis is a better explanation than its alternative. In the second part, she assumes the prominence of inference to the best explanation. And so she said, then we should actually choose a BIV over its alternatives. Okay. So what is this explanatory novelty that should characterize the best explanation, a good explanation? So suppose that you have two theories, T1 and T2, And that for now, they have always used the fundamental deterministic laws of nature. And now think that we found out another phenomenon. Then T1 keeps explaining that phenomena with another deterministic fundamental law of nature. But T2 actually explained that phenomena with an indeterministic law of nature. Okay. Then in this case, okay, of course, T1 is less novel than T2, introduces less novelty than T2. And so T1 should be favored, right? Should be preferred. Okay? Why? Because T2 introduces more novelty. Okay. So here, Nina Emery concentrates, is concerned of a novel type of explanation, not just a novel explanation. So both the T1 and T2 introduce a new explanation, a new fundamental law, which is different from the others. But just because one is indeterministic and the other is deterministic, then we should say that one introduces a novel kind of explanation and the other does not. Okay, so she's concerned with a novel type of explanation. Then the other thing is that Emery understands the notion of explanatory novelty as a comparative notion. So we can say that something is more novel than the other, okay? And so that the brain-in-a-vat hypothesis offers a solution that is less novel than configuration space realism. Okay, but then the problem is, how do you compare different kinds of explanation? Okay, so for instance, suppose that you have to compare non-locality and configuration space realism. So we have on one hand non-locality, right, in a three-dimensional space. On the other hand, we have configuration space realism, which still has locality, but in a higher dimensional space. So how exactly do you compare these two? How do you actually say that one is more novel than the other? So it seems that in most of the cases, you are comparing apples with orange, okay? And then you don't know how to make this comparison. In any case, setting these problems aside, this is how she examines the alternatives that we have for the family of ordinary world hypothesis. So she says, well, non-local connection, I take it that everyone will agree that non-local explanation is more novel than BIV. High dimensional space, I take it that everyone will agree that the high dimensional space explanation is more novel than BIV, okay? And the motivation seems to be, we never introduced non-locality and high configuration space before, okay? So she further says, someone who adopts the ordinary world hypothesis and then appeals to a non-local explanation or configuration space explanation is explaining the EPRB correlation in an importantly different way than the way in which they explain any other phenomena. Okay? If quantum correlations weren't under consideration, all of the other explanations that played a role in the ordinary world hypothesis would involve local dependence, and none of them would involve a distinct physical space, right? So we are introducing high configuration space or non-locality just to explain for that quantum phenomena, okay? Otherwise, we would not need to introduce it. And so for this reason, this counts as a novel explanation. So what about BIV? So she says why the explanation that BIV gives for the EPRB correlation is not especially novel. Why is it? Because it involves causal signaling or originating from a computer to your brain. And we know causal signaling. We have already used it for other kinds of phenomena, okay? And so this is not a kind of novel metaphysical kind of explanation that we are introducing just for the EPRB correlation. Okay? Of course, we might have a puzzle here. I mean, Emery is just focusing on the kind of causal signal here. Okay, so that is where her attention is and nothing else. But of course, we never introduced it before brain-in-a-vat, right, to explain anything else. So she's just selectively thinking of the causal signal, ignoring everything else. Okay. So I think that maybe here it's a good point to pose and to ask what exactly she means by better explanation. So normally in the literature, there is a distinction between better explanation, which is still an ambiguous term, and on the other hand, explanatory power, which is related to explanatory depth. Okay, Emery seems to merge these two concepts, okay, but she keeps insisting on better explanation. BIV provides a better explanation, okay? So there are two ways in which a hypothesis can provide a better explanation. Normally, in the literature, we say that a hypothesis can provide a better explanation because it has more evidential virtues. That is, it is more supported by evidence than another one. And for this reason, this hypothesis is more likely to be true, okay? So we can, when we say, oh, this provides a better explanation, we might mean, well, it has more evidential virtues, it's more empirically supported, okay? And so given this, it is more likely to be true, right? But then there is a second way that in which we can understand a better explanation, which is, well, if that hypothesis is true, okay, then it actually better satisfies the desiderata for explanation, okay? Why? Because it has more explanatory virtues, okay? So on one hand, we insist on evidential virtues, on the other hand, we insist on explanatory virtues, okay? And Nina seems to reason in the second way, so that if it is true, then it has a more explanatory virtues, because if she says, well, suppose that the brain-in-a-vat hypothesis is true, okay, suppose that it is true, then actually provides a less novel explanation than the other, because it's based on a causal signal, okay? And then, so she said, well, if it is true, then it provides a better explanation. So, but what is the kind of explanatory virtue that she insists on? Well, it's less novelty, okay? So only on this respect, okay? So in order to ask, when we ask, oh, does this provide a better explanation? We have to say, well, if it is true, then does it satisfy this criterion of less novelty? If yes, then it's a good explanation. But then, I mean, suppose the configuration space realism is true, and that it's truly the case that we live in a high-dimensional space. Then, in theory, you can actually explain everything in terms of that fundamental reality. Suppose that non-locality is true, and it's the fundamental relation, okay, of this world, okay? Then, for instance, in Bohmian mechanics, if you endorse the factorization of the universal wave function, etc., and then you can derive effective wave functions from the universal wave function, then you can recover local action from non-local action. And so you can actually understand everything in this world with non-local correlation. Okay, so it seems that we can do exactly the same kind of reasoning here for this two ordinary world hypothesis, and say, well, we don't need to introduce anything novel. Fundamentally, everything is local but in a high-dimensional space, or non-local in this space. Okay, so of course it's a problem for those who work on the classical limits and etc. But I mean, also the BIV has the same kind of issue, right? I mean, they, for instance, have to say why exactly is it that we have like the same algorithm that simulates reality can actually produce a deterministic and deterministic or chaotic systems, right? That we kind of experience in this hallucination, okay? So there is still work to do. Okay, if one wants to say, oh, look, we just live in a simulation run by an algorithm. Okay, okay, so a quick assessment, a very quick assessment of Emery's argument for me is just that Emery's argument is wrong. So there might be something that I'm missing here. Maybe Emery is actually, she understands novelty in terms of like divergence from reality. Indeed, in one of her papers in 2019, she actually argues for the minimal divergence norm, according to which we should always choose the kind of hypothesis that less diverges from our reality, okay? So she might want to say, well, look, you know, in a brain in a vat, it's less diverges from our reality than high configuration space or non-locality, okay? But then the question is, well, if she understands this in this way, in terms of the minimal divergence norm, why is it that she's taking our word to be the measure of what is a good explanation or not, if our word is just a false? Okay, so we know that our word is false, so why we should choose a hypothesis that is less divergent from our word? It doesn't make sense, okay? So I don't think that this is what she's doing here, okay? So in the rest of my talk, I just take that the argument is wrong, but I would like to concede that maybe here Emery is actually touching a very important point. Maybe novelty and explanatory power might be inversely related, okay? And maybe radical metaphysical hypothesis might be considered seriously, okay? So now I start with the parse constraints. So what does it mean to provide a better explanation? Okay, so we said that in Emery's paper, there is this kind of mixture between explanatory power or better explanation, okay? What is sure is that she clearly connects a better explanation to the explanatory virtue of being less novel. And so here is my question. Is less novelty an explanatory virtue? If so, how? Okay. So maybe, yes, maybe they are linked somehow, okay? And here in my part of constraints, as I claim, as I said before, I depart from the fact that the BIV is not less novel than its alternative, okay? And actually my claim is that it is a novel, okay? So the BIV provides a novel explanation. And what I would like to argue is that its kind of novelty makes it non-considerable for any scientifically informed metaphysics, okay? So I will argue that novelty and explanatory power have some sort of connection, but only some kind of novelty, not all affect explanatory power, okay? And I will further claim that while other ordinary word hypotheses of standard quantum mechanics are novel, but their novelty is innocuous, okay, and so do not affect the explanatory power, radical metaphysical hypotheses have just the kind of novelty that affect the explanatory power, okay, and so they make them not good explanation, okay. So then the question is, when does novelty pose a threat to explanatory power? When something is novel and for this reason, it's not a good explanation. So I really go to the kind of literature in the methods of, on the scientific method, okay? So if we go into like Popper, Lakatos, Baum's writing on scientific method, then it seems clear that a novel hypothesis is bad and does not provide any kind of explanatory and does not provide an explanation if it does not increase the falsifiability of the theory, okay? So any scientific hypothesis is not ad hoc only when it increases the falsifiability of the theory. Otherwise, it's ad hoc and it does not have explanatory power, okay? So only when it's not ad hoc, then the novelty brings a scientific advancement, and we can say that it provides a good explanation, okay? A hypothesis does not explain, then does not provide any scientific advancement. So of course, the brain in a vata hypothesis, okay, then of course it creates a kind of global unfalsifiability, okay? Radical metaphysical hypotheses are created in such a way to create skeptical scenarios that can never be proved to be wrong, okay? So not only by adding this hypothesis, we do not increase the falsifiability of the theory, but we even reduce it to zero, okay? So that's a wrong kind of novelty. What about high dimensional space and local correlations? Well, hopefully for high dimensional space, we will find a way to prove whether our fundamental space is high dimensional or not. And non-local connections, of course, they are experimentally falsifiable, okay? So what about novelty and precision? So a problem is whenever a novel hypothesis does not exclude more data patterns, okay? So in that case, actually, it's bad for its explanatory power, okay? And well, BIV does not exclude any pattern. It's compatible with anything, okay? So of course, the challenge would be that they tell us what is the kind of algorithm that is used in the simulation, okay? And this algorithm should be so precise to exclude various things, but they haven't done so, okay? What about configuration space realism? Well, it rules out lots of patterns. No locality rules out a lot of patterns, okay? Then this is also linked to the fact that novel hypotheses should increase the predictive power of the theory to a wider range of phenomena, okay? If it wants to have explanatory power, okay? And then, yes, it is true that the brain in a vat hypothesis can predict anything, but once you know the BIV, once you know that you're in a brain in a vat, you can't predict anything because you do not know. I mean, everything is just in the hands of this algorithm, this simulation, okay? So you are not in the position to make any predictions, okay? While for configuration space realism and no locality, of course, you know exactly how the two particles, the two spin are related and where they will go, of course, with 50% of chances, but and this is linked also to the expectations, right? Novelty that does not make the result more likely or more expected, then does not provide a good explanation, okay? And again, knowing that the brain in a vat does not, that you are a brain in a vat does not make us accept the correlation we get, okay? Configuration space and non-locality hypothesis do, right? Then there is something that we said before about empirical support. So I'm justified to introduce a novel hypothesis only when I have also independent empirical support other than the reason for why I'm introducing this novelty. Because if I introduce a novel hypothesis that lacks independent empirical support, then probably it's not very explanatory power. Okay, it can explain just this little thing that is why I'm introducing it. Okay, well, do we have any other evidence for BIV? I don't think so. Okay, do we have other reason for configuration space realism? Probably not. I concede it. For non-locality, we can go to more fundamental theories like loop quantum gravity and have non-locality. Then another reason for why we might be suspicious about the novelty of our hypothesis is whenever the novelty causes a loss of the unification, unifiedness of the amended theory. Okay, so we introduce something and this breaks the kind of unity that the theory had. So for instance, before we were introducing indeterministic law of nature in a deterministic theory. Well, BIV, if it is true, can create a kind of fundamental theory for everything, okay? But then if we are just thinking, well, up to now, okay, up to now, does this hypothesis fit well with the other kinds of explanation or hypotheses that we considered before and that were corroborated before? Well, no, okay. Configuration space realism can have a nice story and say, well, look, you know, we also use configuration space in classical mechanics, just a representation space. We didn't need to reify it, but you can actually explain a classical mechanics and you know, by presupposing the physical reality of a configuration space, okay? For non-locality, well, if we actually find a way to say that our local world and our effective wave functions, for instance, in employment mechanics, really come from the universal wave function, and so locality is just an approximation from non-locality, then we don't break the unification from classical mechanics. Of course, this is a problem of the classical limit. Then it's always suspicious when novelty is used to explain a familiar kind of phenomenon in the domain for which there is already a theory, okay? In this case, the ordinary world hypothesis do not incur in this problem because, well, the quantum EPRB correlations are something novel. So of course, we need to introduce a novel kind of a system. And also we're talking about quantum mechanics, a new kind of theory. So we're kind of expecting some kind of novelty, okay? Then if we look at the metaphysics kind of literature and explanation, then we might also want to say that, well, novelty is bad when it does not explain why to happen something and not the opposite. Okay, so the classical case of explanation. And of course, for the BIV can explain A and not A, so it does not select like the foil, right? So it doesn't say why something else instead, why something instead of something else, okay? Why for the ordinary world hypothesis, yes, I mean, the non-locality between two spins tells us why the two particles are going one up and one down and not both up or not both down if it's the case of the singlet, of course, state. Then if we look at the literature in explanation, again, novelty looks suspicious if it does not unfold dependency relations among variables that we know. And the BIV does not unfold any dependency relations between the explanandum, okay? Why configuration space realism and non-locality do, right? And lastly, novelty is suspicious when does not specify the range of invariance and does not generalize according to like Woodward and Hitchcock account of explanation. And of course, the BIV does not specify this, the range of invariance. Why configuration space and the local correlation do. They clearly tell us, okay, for any singlet state, this is what's happening. For any triplet state, this is what's happening, right? So this is my conclusion. I think that the BIV does not provide less novelty than its alternative. It is a novel, so I'm not buying only a comparative notion of novelty, but also an absolute one. Is there sufficient reason to reject this explanatory power? Well, just because it's a novel? No, because only some kind of novelty are suspicious and constitute a threat to explanatory power, okay? So then I try to characterize the kind of novelty that affects the explanatory power or the explanatory virtue. And I think that this is exactly the kind of novelty that is of the BIV, okay? While other standard quantum hypotheses are novel, but their novelty is just innocuous for the explanatory power. Thank you very much. Thanks.